Hello everyone, my name is Stéphane Girod, Professor of Strategy at IMD and leader of the Luxury 2050 initiative. Today we're running a conversation with Jan Huckfeldt, the Chief Commercial Officer of Climeworks. Why is this important? Because all the indication from climate scientists is that we are living and witnessing an accumulation of greenhouse gas emissions that have been unprecedented and at a fast pace since human came to exist on this planet. So it's really about, in the context of how can you and us make our businesses, our institutions more sustainable and address the challenges that are lying ahead of us. You've probably heard about Climeworks. There's been a lot in the media lately as one of the promising solutions to remove carbon and excessive carbon in our biosphere. So Jan, welcome, and it will be really, really exciting to listen to you. So Jan Huckfeldt, what I find really interesting in his background is that he's had the mix of prominent roles in the big corporate world. He was, after all, the Global Chief Marketing Officer of Motorola, but also has had a big interest into smaller ventures, entrepreneurial ventures like Climeworks since 2022. So Jan has a PhD in polymer engineering and chemistry, and he's also an alum of IMD. So let's jump into this conversation, Jan.
Thank you. Thank you for having me.
You're very welcome. And my first question to you is, before we jump into the specifics of Climeworks, it would be really interesting to understand the landscape of carbon capture, because I believe there are multiple approaches, multiple technologies, and for our audience, in the field of sustainability and beyond, to understand a little bit the stakes, it would be good to understand the landscape first.
Yes, sure, certainly. So I think when it comes to the decarbonization of any organization, whether this is a company or a government, there are basically three ways today. The most important is reduction, and that basically means reducing your carbon footprint by using renewable energies, by reducing the amount of energy needed for whatever the organization is doing. The second is avoidance, and the third is removal. Now, what is avoidance? Avoidance got into bad press over the last couple of years. Avoidance is basically that a company is buying credits, avoidance credits, which ultimately mean they're paying for reduction happening elsewhere. For example, in a developing country, there is a possibility to help with investments to drive renewable energy, and respectively, that reduces emissions elsewhere, and companies can buy those credits. The reason why
offsets fall into that category?
Yes, offsets is often used as a term for that. Why did it receive bad press? Because quite a number of those avoidance credits were found out to actually have a very limited impact on the climate, what we call additionality. So is it really additional to the system which is already existing? And there were a number of concerns. Maybe we can get into that later. And then finally, there's removal. And removal is entirely different from the other two, because here we are taking CO2, carbon dioxide, out of the atmosphere, meaning historic emissions which are already up there. And because our CO2 concentration in the atmosphere is at very high elevated levels, not seen for the past 800,000 years, we do need to actually remove CO2 directly from the atmosphere. And that is what Climeworks, for example, is doing.
Right, now, so let's look at Climeworks, but also other removal technologies, perhaps.
Removal technologies, we would maybe group it into three different areas: nature-based, hybrid, and engineered solutions. Nature-based is rather straightforward. Planting trees, that is reforestation, or afforestation. So the forestry can play an important element, and basically
which has been retreated. If you look at all the statistics about the use of land in the last 100 years, forestry has been constantly retreating. For example, to benefit agriculture and pastures and crops.
urban development.
Exactly.
And so one important effort is to actually plant more trees, but planting those trees in a sustainable way, and that's where it becomes easily complicated. Then you have hybrid solutions, that is biochar, biomass burial, biomass sequestration, enhanced weathering. Enhanced weathering, as an example, is an interesting technology whereby one uses typically limestone. Limestone is a natural occurring stone which actually absorbs CO2, and one accelerates the absorption process by milling it and distributing it over a large surface. And that's a technology which is used at a larger and larger scale, and increasingly successfully. And then you have the pure engineered solutions, and that is BECCS, but it is also direct air capture, what Climeworks is doing. And
so what's the difference between the two?
Well, BECCS is actually a rather complicated process whereby you take wood, forest, which you basically cut, you burn that wood to generate energy, and the CO2 which is emitted is captured and then sequestered. And the idea is basically that you have a sustainable energy source, and the emissions which are generated are captured and ultimately removed from the process and sequestered. That is still a rather complex process to really make sure that the additionality is there. The so-called MRV of these kind of processes are I find rather complex, because it very much depends on the respective carbon footprint of your supply chain from the forest which is cut to the actual reactor, and then it still needs to be captured and sequestered. And finally, there is direct air capture, which is very straightforward in a sense of filtering out the carbon dioxide from the atmosphere, from the ambient air, with the help of a sorbent. And then once the sorbent is saturated, you basically reverse that reaction. You get to pure CO2, and the pure CO2 is then taken care of. It is then sequestered. In case of Climeworks today, it is mineralized in Iceland. So the process is rather simple. We basically mix it with the pure CO2 is then mixed with water and is pumped into the basalt rock. The CO2 water mixture is slightly acidic. The basalt rock is slightly alkaline. You have an acid-base reaction. You get to a carbonate. The carbonate precipitates. It's calcite or marble. It is basically locked away for thousands of years.
On their solutions also, I heard that are actually using the carbon and turning it into components and objects.
Yeah, well, I'm not aware of those, but I think, there is of course in principle the possibility to use the CO2 transformed into, for example, carbonates, and use it as building materials. I mean, that is possible. There are startups existing in that field too. But I mean, if we are, and of course in the cement industry there are startups in that area. You're absolutely right. So the possibility is also to create a circular economy.
Possibly.
I think that's absolutely a possible route to take. In my mind, I'm very simple. I'm actually thinking in first place of how can we decarbonize by reduction and removal in first place.
Yeah, very important. The best carbon is the one that's not emitted, if we can.
Totally.
Right? Yes. Or we talk about carbon, but of course there are other types of emissions. Carbon is the one that stays the longest in the atmosphere, right? And it takes decades or centuries before it decomposes, and that's why it accumulates right now, and that's why we're talking from a science of climate point of view about tipping points, because we never know when we will basculate to something worse because of this accumulative process of carbon. So technologically speaking, we understand the solution. So tell us about Climeworks. Is it already working? Are there plans into the future, or what does it do? So I've read you've signed partnerships with Breitling, with the Lego Group, with BCG. I think at some point, Microsoft came into your shareholders and or invested into. Tell us more about what's happening right now with Climeworks from a commercial perspective.
Yeah, so to start with, Climeworks has actually for the past couple of years now a first of a kind industrial scale operation running in Iceland. And that first one is Orca with a capacity of 3,500 tons per year, which is still small, but it is really the first one in the world, and it is working. I mean, it is working 24/7, and it works at a pretty good efficiency. So if we pull 100 tons of CO2 out of the atmosphere, our own footprint is about 15%. So at a good day, it is even down to 10%, and we believe that this can be further driven to higher efficiency levels.
Just to compare, when you say 3,000 tons a day, is that what you say?
No, 3,500 tons a year.
A year. What could be a convenient comparison to assess the impact or the magnitude of this for our audience? Is it the consumption or the production of emissions of?
Well, that's it.
How many homes, or do you have? Do you know that?
That's a couple of thousand flights to whatever New York and back, right? So that remains small, but it is a first demonstration that this can be actually done. And there were a lot of people for many years who doubted that this can be accomplished, and that is a first demonstration. And in May, Climeworks inaugurated a 10 times larger plant, Mammoth, which is on the same premises in Iceland. Why? Because in Iceland, Climeworks benefits from geothermal energy, which is needed to actually run the adsorption-desorption process. Right. And then as a carbon sink, Iceland has a perfect geology, and that is the alkaline basalt rock, which actually is porous and can adsorb and store CO2 in form of calcite, of a carbonate.
So here you mentioned already a couple of criteria on which you assess the potential of some sites, right? So the underground geology and the proximity of renewable energy sources, right? Exactly. So in terms of next steps and can you stay in Iceland, or would you move somewhere else? In theory, why would you move somewhere else?
Well, in theory we could, but we announced a number of other sites already, one of which is in the US, and there we benefit from tax credits, which are part of the Inflation Reduction Act, and we are in process of planning and ultimately will be building a megaton capacity in Louisiana. So that's one site. There are two other sites in the US. We also announced that we will be working in Canada and in Kenya, among other projects. So we are looking indeed at various sites where we find the right conditions. And to make it simple, it's really the access to renewable energy. It is a possibility to sequester the CO2. And thirdly, you need a, if you want, governmental environment, a political environment, which is beneficial to these kind of infrastructure projects.
Right. Does it matter to be in certain geography, or
it doesn't.
In terms of impact that you want to achieve?
For the planet,
no,
it doesn't.
It doesn't.
It doesn't, because the air circulation is so fast that it doesn't really matter where you remove the CO2 out of the atmosphere.
Right. So 3,000 tons a year with this initial facility, and
10 times larger with the Mamos.
It will be 10 times larger. What's your vision? What's the target aspirations that Climeworks has?
Exactly. You were talking about a comparison earlier. If you look at a coal power plant, a typical coal power plant is 2 megatons in emissions per year. So what it means is from a few thousand tons a year to 2-3 megatons by 2030. That's the ambition. That's a factor 1,000. That's a massive scale. And then to really be climate, to really have a climate impact, I mean, we would need to get to gigaton scale by 2050. So then there are another 20 years to actually scale from megaton to gigaton scale. And
which is another 1,000?
And exactly, it's another factor 1,000. So we are talking then billions of tons. And that's needed because when you look at the current forecast of emissions, we are clearly not on the right path, right? And even within the carbon budget, which was set the last time in 2020, I believe, by the IPCC, we have already used more than half of that carbon budget within the few years since, in the 4 years. And that carbon budget was defined as, I think in 2020 it was defined as 500 gigatons, which is the budget to have a 50% chance to stay within the 1.5 degree above pre-industrial
the Paris Agreement
level. Exactly, Paris Agreement. And to my knowledge, we are now at down to 200 gigatons, and that is simply because of the amount of emissions has not reduced, but it is steadily growing.
Yeah, actually, the Paris Agreement was to be on track. We should be at more or less. We should have already cut 50% of our emissions, and yet last year they were still at an all-time high. So they continue to increase on the back of economic growth, despite the progress of renewable energies in the world, undoubtedly. So there's really an emergency here, which we should not underestimate. One question is, so is it important to think in terms of competition in your industry, or it's better to have multiple players and we should pool up forces? And I was wondering, why someone like Lego Group and Breitling, why do they choose you, and what are the alternatives out there? And what's your point of view on that?
Yeah, my personal point of view is that there is not really any competition. I mean, we as humanity, we need them all.
Yes.
Right? And luckily, there are a lot of new solutions coming up. Even with indirect air capture, I think there are hundreds, close to 1,000 companies. Most of them, however, are in a very, very early stage. And not all will make it, but if you think of these kind of, it's different from founding a software company. Here we are talking an infrastructure project, and it's about molecules, not electrons, and it really requires deployment of your technology, and it's all new technology. You cannot buy that off the shelf. So it really goes from lab to a first demo, to a first pilot, and then a demo, and then ultimately a first of a kind, and then it goes into the maturation of the actual technology and the actual scaling. And Climeworks is at that stage of scaling, right? Most companies which are emerging there at lab or pilot stage, and to get from lab or pilot stage to multiple thousand tons of removal, I think that's easily 10 years of time in between those, right? So it's not done very quickly. Now there are players which are at a similar stage. There's currently none which have the actual capacities already in operation like Climeworks, but 1.5 is one company which is a direct air capture technology, a different one. It is not a solid solvent but a liquid solvent, and they are working on very large scale production sites. So here
is it the one owned by ConocoPhillips or
by Oxy?
Occidental, Oxy, another big oil major. Which leads me to jump into all the potential misunderstanding, window dressing, risk and challenges with these technologies, right? Because a lot of critics say that it's way too little too late, that we won't be able to scale. And you said, you're just a very few already doing and operational on the ground, and we won't be able to actually address in time our collective challenge with these rising emissions, no matter which technology we use, right? And so I would like to get a little bit of your sense about those critics. Some also say, that it's a check for the polluters to continue to pollute. As you know, we have a lot of issues related to the social aspect of oil and gas consumption, which is unequally distributed around the world, consumers having to pay more in fluctuation of the prices. So what's your view on this? What are the obstacles for ramping up scaling direct carbon capture, and to what extent is it not actually betting on too little too late to address our challenges?
Well, to start with, I think it needs to be clearly said that direct air capture alone is not going to help us, right? This talk of we are going to overshoot and then basically save ourselves with
by repumping all the carbon in later on?
With some magic technologies, whether it's direct air capture or any other carbon dioxide removal solution. I mean, for me, that is a completely wrong thinking, and for a number of reasons. That there is an absolute urgency to reduce emissions, and as fast as possible. And there are very clear reasons for that. One of which is, once the temperature is up, even if we remove CO2 from the atmosphere at very large scale, the temperature is not going to be coming down for thousands of years. And that has to do with the inertia of the system, and it has to do with the feedback loops which we have.
The destruction of natural ecosystems and environment that are not restorable and can't play their role anymore.
And equilibriums which have shifted
will be broken permanently.
So the higher the temperature, the more water moisture is going to be in there, the more CO2 is actually going to get out of solution from the ocean and is going to basically saturate in the atmosphere. And as a consequence, you actually have a feedback loop towards higher temperatures. And so even if we pull down CO2 from the atmosphere, that will not actually reduce temperatures for a long time. So that's actually really concerning. It is really that every little percentage or every little decimal of a degree of temperature we need to avoid by all means, and we are clearly not fast enough. So carbon capture, carbon removal cannot be an excuse for continuing to emit. We need rapid action. But
and one question. I mean, I was reading this morning in the Financial Times that, for example, Exxon has just published a report where they anticipate yet further demand for oil and gas by 2050. You know, because the demand for energy is massively growing. You know, now we're in this new wave of AI and the immensely energy consuming, and our lifestyles are based on more and more energy, right? So
well, you know, what is frustrating in that news is that if you look into the investments going into oil and gas and the subsidies which is going into oil and gas pricing, that still is way above any investment in renewable energy. In fact, the increase in subsidies over 2 years, over the past years, is larger than the total investments in renewable energies. And that clearly shows that this is there are still the wrong priorities out there. And I think that has to change, and it can only change through policy. And those policy changes are not comfortable. As we've also seen in France, as an example, the smallest impact felt by consumers. In this case, I think it was the diesel price tag, which went up, created
a social revolt.
Yeah, yellow vest movement, which shows how sensitive the topic is, right? So this is very complicated and complex to deal with for governments, but it has to be done because we are clearly not on the right path.
Yeah.
Now, maybe Stéphane, because you know we talked about is that an excuse? Purely from a business standpoint, if you run a business, you would not be spending more on removal if you can cheaper with higher return on investment, with lower cost, actually reduce your footprint. So it's, for me, there's also not really from a business standpoint, it is not really an issue, because you will reduce your emissions if you are by regulation forced to comply. If we are today in a voluntary market, but if we are moving towards a compliance market. If you're in a compliance market, as a company, you will be not buying expensive carbon dioxide removal credits if you can much cheaper reduce your footprint. And at some stage, you will get to unavoidable emissions, and those you will have to remove from the atmosphere because you cannot compress your footprint any further. And that's the role of direct air capture and other carbon dioxide removal solutions. And
what's your advice for executives to continue reducing the amount of emissions?
Well, that's a large topic, right? I think that obviously goes into all sectors, and it's complex enough because you need to be doing this in a way while running your operations, right? Yeah. If it is a manufacturing business, and it has impact on your supply chain. It has impact on the brand. I mean, this
on growth
and on growth. I mean, this is
possibly
this is by no means
business
easy.
models.
And I think what is the number one hurdle are actually the shareholders, which to my observation are too greedy. And that is also the reason why many of the big companies, despite very good intention by their respective executives, don't move as fast as they could.
Right. Don't you think also there's you and me and everyone's responsibility in this game?
Of course.
Considering the habits we have, and
of course,
changing a few habits maybe would help as well.
Yeah, I think what is typical for us humans is that there's a catastrophe happening somewhere, and everybody is
Oof,
shocked.
it's not me.
And exactly, and
I can continue.
And then you move on. We forget very quickly, and even those hit, many of those find a way to struggle through and continue. And I think it requires a global effort, and again, for me, policy is really required to step up here.
Are policies moving in the right direction?
Yes, they are, but too slowly. So we see tax breaks. We see the first countries to actually do government purchases, which was very important when you think of the solar industry, how solar has scaled. Government purchases were a critical factor. Mm-hmm. So you see first countries to actually engage in that. There's the US, Norway.
China is investing massively also in.
Yes,
in renewable energy farms, for example.
And Japan is very active. So I mean, we see a lot of activity in the EU. You have a number of positive developments, but overall it is too slow given the urgency of the situation.
Right, and urgency, leadership. We've started to talk about this, so it would be interesting to also take your views on. In this environment of the science of climate change, putting us on a more sustainable path, what kind of leadership behaviors and postures does it require from you, for example, at Climeworks?
Well, I think when you're at the brink of innovation, you need entrepreneurship, and you need risk taking. And to enable risk-taking, people need to feel protected in their respective job role to actually be able to take these risks. I think that's an important component if you are really on the edge of innovation and are pushing into areas which are completely new. I personally love the description of your colleague Susan Goldsworthy, and she's talking about having the right balance between having high expectation, stretching your people, and at the same time caring. Yes. And that combination, I think, is exactly the right one, what I would call tough love. You want to make sure that your employees are really stretched, but are cared for.
It's the care to dare leadership approach.
Yeah,
right?
and that ultimately enables also the respective risk taking.
And what do you do to stay on top of your game, Jan, as a leader?
Well, I do yoga and run. I love being outdoors, and from a diet standpoint, I try to avoid sugar where I can, and rather have a high fiber diet.
Right. Okay. So the lifestyle is really important for you, huh?
Yeah. Ultimately, it comes down to nurturing your other brain, which is the microbiome. Right. Which is also a extremely important element of your immune system. and the latest research in that area is fascinating. So we need to take care of our biosphere and our own microbiome.
So it's time to conclude, right? And I would like to ask you, what would you leave our audience with, one or two key takeaways that you would like to leave us today?
Well, many of us and you in the audience are in respective roles in companies, organizations, and I think any effort to reduce and remove is important. We need both. Because as we discussed, to actually get to gigaton scale by 2050, we need to be starting now, because we are talking about a factor 1,000 or 100, depending, until 2030, and then another factor 1,000, which is a massive scale up. It requires billions of dollars. And we don't get to actually financing this unless there's a market. There has to be a demand, and the demand has to be created and has to come from the respective organizations. And so we cannot wait until 2049 or 2040 even, when policy demands us in a compliance market to remove. We have to do it now, because otherwise we will not have the technology when we need it. So it really is that realization that we need to reduce and remove now across all organizations, all industry sectors. And there are very positive conversations which we are having in Climeworks. The prime prospects in our market were those which have high profit per ton. These are financial institutions, professional services, and maybe high tech. Microsoft is the best example. But interesting enough, we actually see even hard to abate sectors starting to move, and that is very encouraging. So hard to abate sectors, whether this is heavy industry or whether this is the aviation industry, they are realizing and have more and more have a long-term view and starting to actually do reduction and removal.
Very good. Thank you very much, Jan.
Well, thank you, Stéphane.
And Climeworks success, and thank you for sharing those insights with us today.
Thank you for having me. Thank you.